What is up, everyone? Welcome back to the Marvel Project. My name's Kieran. Today we're going to talk about projectile motion. So projectile, we know intuitively, it's just something that's sort of launched and takes an arc like this. Alright? It's something that's shot, in the air, basically. And in physics, when we talk about projectile motion, it's something that's shot in the air and that's allowed to continue to fly unimpeded. Alright? So if we have a platform, we're going to shoot a ball off of it. We're going to shoot it with an angle theta with respect to the level. This object is going to fly in a parabolic path. Alright? This path that it traces out is a parabola. I want you to understand something. This has to do with vectors, but we're going to split up the x and y components for a second so you can see what would happen in different scenarios. Okay? So say we shot the ball off the platform, we just dropped it. We didn't give it an x. So in the case where there's no x, what's going to happen? We didn't shoot it at all, we just dropped it. The ball is going to fall straight down because of gravity. Now what if we ignore gravity and we just sort of shot it? Well, it would just sort of keep going straight forever and wouldn't do anything. Well, now because there's an x and a y component, the actual path of the ball is both. Alright, so the y changes under gravity and the x changes as it would normally change. Alright, and so what we can actually do is we can split up the x and y components when we're analyzing projectile motion. Alright, so let's think about now what happens in projectile motion. What forces are involved, or what acceleration is there? Well, it's only gravity, isn't there? You set out an initial velocity, alright? You've got your projectile. You give it an initial velocity, v0. And what acts on it, the rest? Well, in the x direction, what velocity does it have? It just has the x component of v0 because of this vector. This vector has an x component. And what about the y? Well, it has the y component of v0 going up. Okay, this is the x. This is the y. Okay, and we know from the last video that the actual values of these x and y we can find with trigonometry. So this is v0 sine theta, and this is v0 cosine theta. Alright, because those are the vector components of this initial velocity vector. Now we can think. Alright, let's think about this critically. This is a velocity, and we know from kinematics that the only way to change a velocity is with an acceleration. So what acceleration is present when the ball is flying through the air? Alright, so the ball flies through the air, starts here, right there, it flies through the air. What's present here? Well, gravity. Gravity is the only acceleration, and it goes exactly straight down at every point along this curve. Okay, gravity is the only acceleration acting on it. And which direction does gravity act in? Well, it acts in the y. Alright, so gravity, it acts in the y. So what about the x? Well, that means that for the x, there's no net force, there's no acceleration, but there is a velocity. So what do we know? I know the velocity in the x direction is a constant. Okay, and this constant value, it's nothing but the initial velocity times the cosine of the angle present. Cosine theta. So how do we find the displacement from this? Well, it's the constant velocity, and actually what we can do is we can use our equations of kinematics. Okay, and we know from the kinematics equations that displacement in the x direction is equal to velocity, alright, which is v naught cosine theta, times time, plus an initial condition. Alright, so what's that initial condition? That initial condition is the initial velocity. Okay, or is the initial displacement. So, what's the initial displacement in the x? Well, if we mark the starting point as 0, and everything beyond is positive x, then we see that there is no initial displacement in the x. So for projectile motion, its x and y, its x velocities and positions are always given by these equations, granted that you consider the initial position of your projectile to be at x equals 0. Okay, and why doesn't this work for y? Well, because if we have if we're doing it in the y, the y component of the vectors, we consider this as an initial displacement in the y. Alright, this initial height, this cliff that you shoot it off of, that's the initial displacement in the y. Alright, so we can always keep y positive. So that's for the x. Okay, and we know now the x velocity at any point is constant, and the x displacement changes linearly with time, and that should make sense. Okay, if you have a constant velocity, you're gonna move at a constant pace, so your displacement will grow linearly. Okay, now what about right here? What about for the y component? Alright, so what do we know with the y component? We know we have an initial displacement in the y. Alright, so we have a displacement in the y, initial, and we know we have an initial velocity in the y. Okay, initial velocity in the y, and what do we also know? We have a constant acceleration in the y, and what's that? It's gravity, which equals gravity. And we can think of this acceleration vector as always going down. So which way are we going to set our directions? If we set up as positive and down as negative, then we know that the acceleration is equal to a negative value for gravity, and that's 9.81 meters per second square. Right, so a negative 9.81. So what can we do with the y? Well, we know we have an acceleration, we have a constant acceleration, and we have an initial velocity. So we can use the equations of kinematics for the y component. Alright, so what's velocity in the y? Well, we know acceleration, okay, and so we know that the velocity will be nothing but acceleration times time plus an initial velocity, which is v naught sine theta, because that is the initial velocity in the y direction. Okay, what about displacement in the y? Well, we can use our kinematic equations again. We have velocity and we have acceleration. We can find displacement. Alright? And just using our kinematic equations, we can see that the displacement in the y will be minus gt squared over 2 plus v naught sine theta plus the initial displacement in the y. Okay, plus the initial y value, which is right here. It's this initial value. Okay, so that tells us how those are moving. Okay, it tells us how the components change at any given point in time, but how does that help us? Well, what do we know? We know that we have the components of the vector, so we can find the original vector at any point in time. Okay, because we know what acceleration in the y and acceleration in the x. Okay, because we know acceleration in the y is always minus g. We know acceleration in the x is 0. So we know the acceleration vector. It's always minus g going straight down. What about the time variant vectors? Alright, so like velocity. velocity in the y changes. So what do you know? You know if the velocity in the y is changing, then the actual velocity changes. So the velocity of the object will always look something like this. And if you notice, this right here, it's tangential. It's always tangential, the velocity, to the parabolic path that's being traced out. Which makes sense because it's the change of that parabolic path. So it's always the tangent to it.